We demonstrate our annotation framework and its accompanying graphical user interface. The interface contains the current annotation image, an array of buttons for moving forwards or backwards in the sequence, as well as a graph of the predicted errors of each annotated image, from which it is also possible to jump to a specific frame. We begin by annotating the three people. The green bounding boxes show positive annotations. The frame is then marked to be used for training, and training begins when the user clicks train. While the Huff Forest is training in the background, the user can continue annotating other frames. Here we have jumped forwards. We again mark this frame to be used for training. The training which runs in the background is fast enough that by the time we have finished annotating the second frame, training is complete and can be incrementally updated with the new annotations. As the detector runs over the other frames, the predicted error is plotted in yellow. Hypotheses generated by the detector are shown as blue bounding boxes. If we validate the hypotheses for a frame by clicking OK, then they are accepted as being annotated and changed to green. The predicted error for that frame then goes to 0 and, like training frames, gets marked in red on the predicted error graph. Suppose we now jump to the middle of the sequence. Instead of waiting for the detector to proceed to the selected frame, we can force it to the top of the queue by clicking Test. Testing now continues from the current frame. We can fix the false negatives and update the Huff Forest by marking it to be used for training. Now, as we jump forward to the next frame and apply the updated Huff Forest, there are less false positives than the forest previously trained, so we only need to make a few corrections. With one more update, we are able to capture all persons correctly. We note that up to this point, the video has been captured in real time.